Hello students, in this video we will see about the projection of planes, how to draw the projections for a plane in the AutoCAD software. First we will see what is projection of planes. Okay, what is a plane? A plane is a two-dimensional object having length and breadth with negligible thickness. Okay. So these are the different shapes. We can consider it as a plane. Okay, a plane is a two-dimensional object. So for drawing this, for making this projection of planes, so we will have 6 different conditions here. So these are the 6 different conditions. First one is plane parallel to VP perpendicular to HP, plane perpendicular to VP and parallel to HP, and third case is plane perpendicular to, sorry, remove this one, plane perpendicular to both VP and HP, plane perpendicular to VP and inclined to HP, planes inclined to VP and perpendicular to HP, and plane inclined to both VP and HP. We will see a one example for each case, and I will draw the projections in the AutoCAD software. So now before seeing the example, we will see how the projections will come for each conditions. So if you take the condition 1, plane is perpendicular to HP and parallel to VP. So now the shape considered is a square shape. So here you can see this is the first quadrant. Take it as a first quadrant. This is horizontal plane HP and vertical plane. So now the object is placed. The plane is placed perpendicular to this horizontal plane and parallel to this vertical plane. So when you see from the front, you can get the true shape of the object. So when you see from the front, we can get the true shape of the object. The true shape of the object is projected onto this vertical plane. So that means front view. When you see from the front, you can able to see the true shape of the object. So whenever you drawing these projections of a plane, first you have to draw the true shape. First we have to identify on which plane we are getting the true shape. So first we have to start drawing the true shape for the particular shape given in the problem. So here you can able to get the true shape on the front view. So front view you always have to draw it on the vertical plane. According to this first angle of projection, the vertical plane falls above the reference line. So we have to draw the square on above the reference line. But when you see from the top, you can able to see only a straight line. So that straight line you have to draw it at the bottom. So before drawing this horizontal line at the bottom, you have to project the line from each corners from the front view. So here they have projected this light color green, means the line without any thickness, which is projected from the corners of the square. We have to project this line and we have to connect both the projected lines, and then you have to come up with the top view. Simply you can't put a line, that is not correct. Okay, we have to project lines from the top view and then we have to connect the projected lines to get the top view. Okay. So next we will see an example for second case. Here see a plane is perpendicular to VP and parallel to HP. So now the square should be placed in in this way. So in this manner, when it is placed like this, it is parallel to horizontal plane and perpendicular to vertical plane. Now you can able to get the true shape of this square when you see from the top. So first you have to draw the top view and then you have to project a line from each corners of the squares from the top view, and then you have to connect this projected lines to get the front view. So when you see from the front, you can able to see only the corners A and B. Okay, the corner A and B is only visible to you when you see from the front, whereas the corner D and C are the hidden corners which lie on the same line, of the corner A. Okay. Similarly, the corner C lies on the same line of the corner B. Okay. So hidden lines you have to mention it in the bracket. So hidden corners you have to mention it in the bracket, whereas visible corners you have to mention it openly without any bracket. So here the Here A and B are the visible corners, so they have mentioned it openly. D and C are the hidden corners, so they have given it in the bracket. So next we will see condition 3. Condition 3 is the plane is perpendicular to both VP and HP. So if you place the plane perpendicular to both vertical plane and as well as the horizontal plane, you will just get a line on both the planes, okay, in like this. So now we will see uh, how to draw this uh, projection of projection for a plane in the AutoCAD software. Now we will start drawing for condition 1. Now you consider this problem. So according to this problem, a square lamina ABCD of side 40 mm is perpendicular to HP and parallel to VP. Okay, this is condition number 1. The object is perpendicular to HP and parallel to VP. According to this condition, you will get the true shape when you see from the front of the object. Okay, so first you have to draw the true shape. The true shape you will get on the front view, that means on the vertical plane. You have to draw the square for a given side of 40 mm. So go to the software. First draw the reference line. Press F8. So I'm drawing it for 300 mm. So I'm taking it randomly. So next text. Click on the first start point. Specify the height as 5. Angle of rotation 0. Type X. Type Y. Above the line it is VP. Below the line it is HP. Okay. So after giving the text, you draw a square for side of 40 mm. So you will get the true shape on the front view. So front view will comes on the vertical plane. So start from here. So draw it for 40 mm. Go up again 40. Move to the left 40. Come down and close the. So now the distance of this base side of the square from the reference plane, you can take it randomly. Okay, they didn't give any values for this distance, so you can take this distance randomly. Now once you got the true shape, first give the names for corners. Then so now click on the corner letters and change the letter names. Then project line from the corners of this front view. So corner A you draw a line, which is again you take it randomly. Okay, there is no any particular length you have to length you have to use it here. So you can take it randomly. So take it 60. Similarly from B also you take it for 60 mm. Okay. Now you have to connect this. You have to connect both this projected lines and you have to get the top view. Okay. So to differentiate from the construction this projected lines, so we have to increase the thickness of this. Go here, increase the thickness. So if it is not visible, after I increase the thickness but it is not reflected on the screen, so here the line weight option is switched off. So select this, make it on, as well as you click this also, click the top view also and increase the thickness. Same, you can change the color also. So now After drawing both the views, top and front view, then go to dimensions, linear dimension, mention mention the dimension for any one length of the square. This is 40 mm. So after drawing it, what you have to write at the bottom? You have to write text. Start from here. Height of the text 5, angle of rotation 0, and you have to write all dimensions are in mm. This statement is very mandatory because when we are giving the dimension, we are giving only the dimensions, not the units for the dimensions. Okay. So we are writing it commonly at the below, at the bottom of this drawing. Okay. So now we'll see the next case. So now the second case. The question is a square lamina ABCD of side 40 mm is perpendicular to VP and parallel to HP. Okay. So now the plane is placed parallel to HP and perpendicular to VP. In this condition, you will get the true shape on the top view. So when you see from the top, you will get the true shape. This top view falls on the horizontal plane. So first you have to draw the true shape on the horizontal plane, and then you have to project lines from the corners and you have to get the front view. Again, go to the software. Now you have to draw the square at the below the reference line. So you can start from any distance from this reference line because they didn't give that condition that this one side of this square should be in this much distance from the reference line. That is not given in that question, so you can take it randomly. So I'm starting this from here. F8 40, again 40, on the left 40, and then finally close it. And then now take line and project it from the corners. Again, this length is random, so I am taking it 50. So you have to project from all corners, again 50. Now connect these two projected lines. Okay. Now select all the sides of the square as well as the line which is above this reference line. This is the top view. So select and increase the line thickness as well as the color of that line. Now you have to give the naming. So Control V. So this I'm going to take as A, this B, copy C, put it here, copy D and put it here. So here at the top we have to mention the corners. So here, so in the previous case I didn't mention the corners, letter for the corners on the top view. So here D is the, when you see from the top, D is the visible corner, A is the hidden corner. So put A in the bracket, put A in the bracket, whereas D you type openly. Similarly, put B in the bracket, and type C without bracket. So in in case 2 also, in condition 2 also, in second problem, so when you see from the front, you can be able to see only A, whereas D is the hidden corner. So select A, copy, put it here, double tap. A is the visible corner, whereas D is the hidden corner. Similarly, select B, put it here. put C in the bracket. Now go to dimension and give the dimension for any one side of the square. So this is the projection for condition 2. Condition 2 is the plane is perpendicular to VP and parallel to HP. Okay, you can draw the projection for these conditions for any shapes. Okay, not only for square, for even for rectangle or pentagon or any polygons, you can able to draw the projection by following the same method. The first you have to identify, based on the condition, you have to identify on which plane you will get the true shape. First you have to draw the true shape, and then from each corners you have to project one lines, and then you have to connect all the projected lines accordingly. Then you have to get the other view. Okay. Now we will move on to this next case. Next case is a simple one. So which is this case. Okay, the line is perpendicular to both VP and HP. You will just get a line on both the planes. Whatever the shape, you will just get the as a straight line on both the planes. So we will skip this condition and we will move on to the next condition, which is little bit tricky. So which is that the condition is a plane is inclined to HP and perpendicular to VP. Okay, we will see a problem based on this condition. So you take this problem. So in this question they have given a pentagonal plate of side 30 mm is placed with one side on HP and the surface inclined at 50 degree to HP and perpendicular to VP. So before start drawing this projection for this kind of problems, that means when the plane is inclined to any one plane, that means horizontal or vertical plane, you have to approach the problem by assuming that there is no inclination, that the given plane is parallel to that corresponding plane. For example, so you take in this problem they have given the surface is inclined at 50 degree to HP and perpendicular to VP. You don't alter the second condition, you keep as it is, that it is perpendicular to VP. But the first condition, it is given inclined at 50 degree to HP. This condition you assume that it is parallel to HP. Okay. So first we have to draw the true shape and then only we have to get the projected shape. Since it is inclined to some angle with some angle to any planes, you will not get the actual size of the object. Okay. The projected size will always be lesser than the actual size. So first you have to draw the actual size or the true shape. So that you will get only on condition 1 and condition 2. That means it should be parallel to one plane and perpendicular to other plane. Then only you will get the true shape. So here we are assuming that we are neglecting the 50 degree and assuming that the plane is parallel to HP and perpendicular to VP. First we are drawing the true shape. From this true shape we are projecting lines and then getting the projected shape. Okay. So according to this, what I am going to assume that the condition is, so I am neglecting this angle and I am assuming that it is parallel to HP and perpendicular to VP. So this is case number 2. Okay, this is case number 2. Okay, this is parallel to HP and perpendicular to VP. So according to this condition, case 2, condition number 2, you will get the true shape on horizontal plane. And when you see from the top, you will get the true shape. The top view you have to draw it on the horizontal plane. So in this software, so on the same, I'm going to use the same reference line. So I'm just going to extend it. I'm click this Y and I'm going to the end of this reference line. So first I'm going to put a pentagon below the reference line. So So type polygon, enter, and it asks you to enter the number of sides you enter. For pentagon, pentagon consists of 5 sides. You enter 5, enter, and you have to select here. Can have two options to draw any polygon. One is by giving this center of polygon, or another one is the edge method. If you use this center of polygon method, it will ask you to specify the radius of the circle that is subscribed or inscribed in a polygon. Okay. So we don't know the radius of the circle that is inscribed or subscribed around a polygon. Okay. So for that, here we know only the length of a side. Okay. So I am going to select edge method, and it will ask you to select the first point. So I am going to select the first point below this reference line, because we are getting the true shape on this top view. That means which we have to draw it on the horizontal plane. So I am starting here, and then you have to mention the length. Length is 30 mm. So now I got a pentagon for 30 mm. Okay. So if this distance of this pentagon from this reference line, again this distance is a random one, so you can take any distance you want. They didn't mention this distance in the question, so we can take it randomly. And the next thing is we have to name the corners. So starting A, B, after placing it, you change it to E. So once you got the top view, means once you got the true shape, so take line and project from each corners until this reference line. Again you start from corner B. This corner B and corner D lies on the same line. Okay, so you extend this line up to this reference plane, and again take a line, start from corner C and go up to this reference line. Okay, so after putting this projected lines, again take a line and you have to connect all the projected lines, all the end point of this projected lines. Okay, don't put a single line. See, I have connected first two projected lines, end point of the first two projected lines, and then from the second end point of the second line, I have connected the end point of the third line. Okay, so don't put a single line. You have to draw it. You have to go by end point to end point. Okay, from the end point of the first line to end point of the second line, again from the end point of the second line to end point of the third line. So next, after putting the line, now you have to mark the corners with the help of alphabets. So here we couldn't able to differentiate the corners. So what you do, you put a point at the corners. Put a point here. So I put a point, but it is not visible. Since you go and change the point cell, since the default style is a point, we couldn't able to find there is a point is there or not. So go and change the style. Okay. Reduce the size to 4 and set size in absolute units. Click OK. So I put a point here, and I'm going to put one more point at this, and same at here also. Okay. So after putting the points, you have to name the corners. You have to give the name to the corners. So when you see from the front, okay, this front, A, B, C are the visible corners, whereas E and D are the hidden corners. So put A openly, double tap, and put E in the bracket. Okay. So to differentiate, what you can do, so you can use A dash, E dash for mentioning one side of the view. So to differentiate the letters between the top and front view, so on so I am here, I am taking for the front view. For the top view, I am taking without any hyphen, whereas for the front view I am putting one dash, A dash, E dash, Next, put B, double tap, and put D in the bracket, then copy C, you should see here. Put it. Okay. So we will put a dash representing it is a front view. Okay. So if we put a dash, we will take it as a front view. Without dash, we will take it as consider it as a top view. So now we will come to the question. Now in the question what they have given, now the surface, now you come to the question, the surface is inclined at 50 degree to HP. Now you mark this 50 degree. Okay. So by assuming it, by neglecting this inclination angle, we have drawn this projection based on the condition 2, that is parallel to HP and perpendicular to VP. So after getting this, what you have to do, now you mark that inclination, which is given as 50 degree to HP. Okay, it is given 50 degree to HP. So if this 50 degree to HP, you can able to realize when you see from the front. Okay, the front view you always have to mark on the VP. Okay. If it is given 50 degree to HP, you have to mark it on VP. If it is given 50 degree to VP, you have to mark it on HP. Okay. It is a vice versa. So now go to the software. So what I'm going to do, I'm going to move this front view along with the letters. So select all the letters along with the points as well as the line. Okay. So after selecting all the thing, go to move, click on move. Take, now it is asking you to specify the base point. You take C as base point and you drag and you move on the same reference line. So go some distance. So again this distance is random. So you have to place this line without intersecting with this, with its original line. Okay. Move. So don't move. So sorry, if you move this original, the master copy will disappear. So instead of moving, you click copy and select C as base point and you move it to the right. So you have to place this line without intersecting its original line. Okay. So I placed it here, press escape. Again select all this points, lines as well as the corners and you click on this rotate option. Now we are going to rotate this line about A. So select A as your base point. It is asking, see the comment box, it is asking specify base point. Select, click on this A and you give 50 degree. So see, now the line is rotated by 50 degree. If you want to check the angle, go to the dimension, select angular dimension, select these two lines. You can able to check also. So you can also ensure that the angle is 50 degree. So once you rotated this front view by 50 degree, next you have to project a vertical lines from all the corners. So again it is for a random length. So project 3 vertical lines from 3 corners. Okay, similar way from the top view also we have to project line from each corners in the horizontal direction. So you have to draw this line in such a way that it has to cross all the vertical lines we have drawn from the front view. Okay. So from each corners we have to project one horizontal line. Okay, after projecting this lines from corners, both from front as well as top view. So now we have to mark the corners here. So first take the corner A. This is line A, and you have to check for the line A from the top front view. So this is front view. So these two lines are intersecting at this point. At this corner is your corner A on the projected shape. Okay. So now I'm going to put a point at the intersection type point. Put a point here. Again, now move to the corner B, and this is line B, and find out the line B from the front view. So both these lines are intersecting here. This is corner B, and similarly find out the intersection for corner C. This is corner C, and this is corner D. This is corner E. Okay. So again we have to mark the corners. So place the letters close to that point. You give A1. Okay, now copy B, put it here. This is B1. 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 E1. So once you mark all the corners along with the names, along with the corresponding names, now take line. You start from A, connect A to B, A to C, T, E, and again you have to connect E to A. Okay. So once you connect all the corners, so to differentiate, select lines and increase the thickness and also change the color. Now if we compare the size of this projected pentagon to the actual pentagon, the size is reduced. Okay, if the plane is projected at some angle or some inclination, so if you are projecting a plane with the plane is making some inclination with any one of the planes, the size of this projected plane is always lesser than the true shape of the plane. Okay. So below this you have to write all dimensions are in mm. Okay. And also you have to give the length. You have to mention this length of a side of a pentagon. Okay. Now next we'll move on to this next case. We'll see an example for next case how to draw a projection for case 5. Next we will see a problem on fifth condition. The fifth condition is the plane is inclined to VP and perpendicular to HP. So take this example, a hexagonal plate of side 30 mm as one of its corner, side 30 mm as one of its corner on HP. Its surface is inclined at 50° to VP and perpendicular to HP. So now go to this. Now first what we have to assume is that we have to neglect this inclination and we have to assume the condition 1, that it is parallel to VP and perpendicular to HP. So for this case, by assuming this, for this case first we have to draw the front and top view. So according to this case you will get the front view, so you will get the true shape on front view. That means on VP you will get the true shape. So first draw the true shape to the software. So on the same reference line, I'm going to draw this. So I'm going to extend this. Okay. Now they have given hexagon with its corner, with one of its corners is resting on HP. Okay. So now we will draw the projection assuming that it is condition 1. That means there is no inclination. Instead of inclination, we assume that it is parallel to VP and perpendicular to HP. Okay. For this condition, you will get the true shape on the front plane. That means on true shape on the front view, that is on vertical plane. So type polygon, enter. The number of, since it is a hexagon, you have to enter 6. Specify the center of the polygon. No, don't use this center polygon method, because if you select this center polygon method, it will ask you to specify the radius of the circle that is circumscribed or inscribed here inside that hexagon. So you always have to use this edge method. Select edge method, specify the start point. So you have to draw the hexagon in this manner. So press F8 so that you can get it in a straight line, and the length should be, what is the length given? 30 mm. So specify 30 mm. So you have to draw the hexagon in this way. Since they are told, and since in the question it is given that it is resting on one of its corner. Okay, one of its corner lies on this horizontal plane. So for this condition, you have to draw this hexagon in this way. If it is given, if it is one of its base side is resting on HP, then you have to draw the polygon, this hexagon, like this. So you have to use the edge method. Entering 6, select edge. So you have to draw the hexagon like this. If it is given in the question that the hexagon is resting on one of its sides. So here it is given the hexagon is resting on one of its corner, then you have to draw the hexagon like this. So I am going to move this hexagon close to this. So click move, click this one as well. Try to bring close to this reference line. We don't know the exact distance, at what distance this pentagon is from this reference line. We don't know this distance of this base edge of this hexagon to this reference line. So we are taking it randomly. So now you give the names to all the corners using the text. So I'm going to copy from here. So I'm going to start, this is B, this is A, C, D, E, F. So next, now we have drawn the front view. So to get the top view, what we have to do? We have to project lines from the corners, from all the corners. So the true shape up to this reference line. So since in the question it is given that this one of this corners is resting on the HP itself, so I extended this projected line only up to this reference line. If they are given the distance that the corner is some 20 mm above or 20 mm in front of this VP, then that can, at that time what we have to do, we have to mark that 20 If it is given 20 mm in front of VP, then we have to mark that 20 mm here. Okay, if the corner is lies 20 mm in front of VP or 20 mm above HP, then you have to mark the distance here. But here the distance is not given in this question, so I instead they are given this one of this corner is resting on HP, so I stopped this projected line up to this reference line. So now take a line and now connect this end point of this projected lines. So you have to connect end to end. Okay. So don't put it as a single line. Here see I have 3 lines. Okay, between 2 projected lines, end point of 2 projected lines, you have to make a line. So after putting a line, then you have to give the corners. This is a visible corner. Now take E. So we will mention it dash. Where in the front view I didn't put any dash for the letters. So for the top view I'm putting dash. E is the visible corner, whereas A is the hidden corner. D dash, B dash. Next copy C and put it C here and change it to C dash. So once you got this projection both front and top view for this assumed condition, the condition we assumed is parallel to VP and perpendicular to HP. So after this, then we come to this inclination angle. This inclination given is 50 degree to VP. If it is given 50 degree to VP, we have to mark this 50 degree on HP. So go here. So what you do, you select all 3 lines along with the letters. Before this, we will put a point on each corner so we can able to identify these corners on the top view. So now you select all the lines, letters along with the points, corner points. Now click copy and select C as your base and then move it to the right so that it should not interfere with this master copy. So I'm going to place it like this. So now again select all the points, lines and this letters, and we have to rotate it by 50 degree. So I'm going to rotate it by 50 degree. So click rotate. So I'm going to rotate it about this F dash. Click on this F dash and give, I think the angle is anti-clockwise. I want to rotate it in the clockwise, so I'm going to give -50. So to ensure that it is 50, take an angular dimension and check what is the angle between the inclined line and the reference line. So now project vertical lines from all the corners of the top view. Similarly, from the front view also, you have to project the horizontal direction. So after projecting these lines in the horizontal direction, now we have to mark the corners. Okay, start from A, select this is A line and this is A line from the top view. So both are intersecting here. Type point, put a point here. This is point A. So next point B. Okay, this is point B. Next point C. This line, this intersection is point C. This intersection is point D. This point E. This is F. So now you will give the name. So this is A1, A1, B1, B1, D1, this E1, put it F1. Okay. So once you got all the corners, let us for all the corners. Now you start connect all the corners using line option. Take line. Start from A to B, B to C, C to D, D to E, E to F, F to E. So once you connect all the corners, select all the lines. Select all the lines. Change the line thickness as well as the color. Top you change the line color. Select only this line. Change the line thickness and change the color. Now this is the projected view for the given hexagonal plate. So now we have seen we have drawn the projection for 4 different conditions: condition 1, 2, 1, 4 and 5. So we will see the for the next condition in the next video, which is little bit a bit complicated one. So what is the projection when the plane is inclined to both the planes? Okay, and the object is when the given the 2D object is inclined to both the planes. Thank you.